When you're working on a project with other people in LogixPro, a lot of times what will end up happening is you'll write some code, your friends in your team will write some code, and you need to put those two pieces of code together. And there's no good way to do it in LogixPro itself. Let me show you a trick for combining programs, and this should save you a whole lot of time. I've brought up a fairly simple program from fall of 2016. It's called Mapping I/O and Verifying Boolean Algebra. It consists of some instructions for mapping I/O, and all that really means is that you copy all of the inputs to a memory location and work off those memory locations as if they were the inputs. Now this has some advantages. One thing it can do for you is if you change some of the inputs, it can keep you from having to go through your code and change all the references to that particular instruction. In fact, I've used a move instruction here to simply copy the entire word, but the way you normally would do this is copy each bit of the input word separately on a separate rung to another bit of a word in memory. In my case, I'm using the address 1 in the binary table. But you would copy each bit, that way later on if you needed to change where an input was wired, it'd be easy to change which bit that is copied into by changing one rung or flipping two rung addresses. Anyway, that's a side point. The point I'm trying to get at right now is understanding how we can take a program like this and combine it with other code. So this is a simple program. There's some outputs here that are also mapped at the end. I'll let you look into that. In the middle, I've got some instructions that I was working with some Boolean algebra and wanted to verify that I had solved or simplified the equations correctly and that I got the same results. So if I remember right, this rung 6 is the non-simplified version, and then the simplified version is down here on rung 8. It relies on rung 7. Anyway, so we've got some code here, and let's just say we want to add. Well, the first thing to do is to understand how the program LogixPro saves this. It turns out you can open the files that are made by LogixPro in Notepad. They are .rsl files, but you can open them as text files. This is the file I have open, so I'm going to right-click, and in Windows 7, which I know is a little old, but I can say Open With. You'll have to figure out how to open it in a text editor in your operating system, but it needs to be a very simple text editor. You want to save this as just plain text. You don't want anything special, any special characters or anything. So I'm going to open this up in Notepad, and then I'm going to move it over here where we can look at it. And this code here, this text, is exactly what you're seeing over here. Let me show you the structure of it. For example, SOR. I don't know what SOR stands for. I imagine R is for rung. I know this is rung 0. Well, look on rung 0, what do we really have? We have a move command. Oh, well, that makes sense. Here's move. We're moving input word 1. Well, that's addressed right over here. I hope you can see it on the video. To the binary table, word 1. Well, that matches exactly. And then EOR, I guess, is end of line 0. I'm not sure. I don't ever go into this Notepad and edit my programs here. I just edit them in LogixPro and then open them up in Notepad when I want to copy whole sections from another program and paste them in and make them match. Now, one thing you have to be careful about is if you copy a code from another program and you paste it in here, you have to change the line numbers manually. That is one thing you have to do. So it's really important to understand that this is rung 0, rung 1, rung 2, and so on. Let's look at rung 2, for example. Rung 2 is right down here, and rung 2 first references a bit. It is timer 4's done bit. And you look and see what it is. It's an XIC. That's this type of instruction, examine if closed. And it references this particular bit, timer 4's done bit. So this is actually very simple. And then there's a count up instruction, CTU. That makes sense. That's the next element on the line. And then C5, 0, so that's counter number 0 in the counter's memory. The preset value is 32, and of course there's no accumulated value on this rung because that's not part of the program. The programs always start and the accumulated value is 0. And then our end of rung 2, I suppose, is what this is. So if you look at this line by line, you'll notice that all of this matches. Rung 6, for example, is a little bit longer. I had to break the line in Notepad, of course, but rung 6 consists of XIO, B3 1/0, that makes sense. And then there's a BST, I guess, is a branch. And these things must be what's in the branch. There's a branch nested. I'm not sure how it does that exactly. It doesn't matter. The point is, the only thing I care about is the fact that this is rung number 6, and if I want it to be a new rung number, I can change the rung number. Now, I've never tried just in this file changing it to say rung 20 or something, which is more than the rungs I have. What I've always done, or where I've needed this, is where I've had code and I wanted to copy other code in and use both at the same time. Now, another piece of information about this, you'll notice that it says File Ladder 2 at the top. That corresponds to this tab down here, Ladder 2. There are subroutines you can call also, and you can put code in here as well. So a lot of times what you'll want to do is copy code into a subroutine. How do you do that? Well, the easy way, if you notice, you've got, let's see, let me go back to my ladder. We've got a total of, what? 9 rungs in ladder 2. So this is the last rung right here. And notice that there is an RCM, a rung comment. I'm pretty sure that's what that stands for. And it goes with rung number 9. And what I've commented on this rung is map outputs. So there's my rung comment. Well, immediately following that is SOR10 end. Well, that's a valid rung also. There is actually a rung 10, which is the end. But after that is a new file. It's subroutine 3. That's actually right here in the subroutine. And you'll notice that there's just a single rung here. It's rung number 0, and it's an end. And then there's no rung comment for that particular rung. If I were to add a comment here, save the file and reopen it, it would appear on this rung comment line. And then similarly, file number 4 or subroutine 4 here is this one. And so you could literally write code in ladder 2, and one of your team members do that. Open it up, copy it all, copy whatever rungs you need, and paste it into a subroutine. Or you could copy it and paste it at the end. Now you'll want to put it before the end rung. So for example, if I were pasting into the main ladder, I'd insert some space here, and I would paste in the code that I'm copying. Of course, you don't want to leave any spaces after you do your paste. You want to make sure that line after line has information on it. So that's how you can copy over. It's a really simple process once you understand it. And of course, you can just say file saved. Now, what else is saved? It's important to know what else is saved in these files. There's a bit table. That's what BTBL stands for. And bit table is just the data in the binary file. So if you look at the binary file, you'll notice that bit 0 of word 0 is on, and that's what this represents. These would be, if I remember right, these are in decimal. So if we look at it, rather than as binary, if we look at it as decimal, then you see 1 and 15. Here, sure enough, is 1 and 15, and then zeros for the rest of the file. What that really means, that's storing which of the bits are on and which are off. And the rest of the table, all 100 words, 0 through 99, are stored. So if you counted these zeros plus the 1 and the 15, you'd find that you've got 100 rows here. The next thing that's stored is the integer table. That's what NTBL stands for. If we go and look at the integer table, you'll notice it's all blank. There's no data stored in there in my program. And so, not surprisingly, oh, it moved up. Let me go back down. There we go. Not surprisingly, for the integer table, all the values are just 0 or null. It also saves the float table, which is a place where you can store floating point numbers, although for what we're doing, we're not using floating point numbers. And then finally, at the end, it saves the symbols. So if you noticed, back in ladder 2, I had named several of the addresses. For example, B3:1/0 was named B. Well, let's see, 1/B3:1/0. I know it's got to be in here. There it is, right there. So there's where LogixPro saves the name of the addresses that you have chosen to name. Notice I did not choose to name T4:0/DN. I should have in my code. That would have been cleaner. Had I named it, it would appear down here. Now sometimes, I will warn you, LogixPro has some bugs. Sometimes when you rerun a program after making a change without downloading, I can't remember the exact sequence, but LogixPro, once you save, will completely get rid of all of your your labels, and it's extremely annoying, or it gets rid of part of the labels and you can't remember what's what. What it's doing is it's actually getting rid of the end of the file. For some reason it's not writing the whole file properly. And I'm not sure if it sometimes doesn't write the floating point and integer and binary table as well. I'm not sure how far the bug goes, but it's very frustrating. So I do recommend saving versions of your program to make it work and to be reliable. For the fun of it, let's open up another program and let's insert some code so I can show you how to do that. I'll just open whatever simple program I can. Let's see, let's try, I want something simple. Math and binary coded decimal, BCD, that should do. So I've only got 4 different instructions here. And what I want to do is I would like to open this up and copy this program into the one you've already seen. So let me go back to the mapping, I/O, and verifying Boolean algebra program, and you see that right now there are only 10 rungs if we include, well, I guess there's rung number 0, so there are 11 rungs, including the end rung. Now what I'm going to do is I am going to open Math and BCD with Notepad. And you'll notice there are no really interesting things in the subroutines, which are down here. There's only 4 rungs. There's no rung comments. I am going to copy these rungs, so Control-C. Notice I didn't copy file ladder 2. I didn't copy anything else, and I don't need any of the bit tables or any of that stuff. And there's no labels in this. There are no symbols. So I've copied all of this. Let me double check, make sure I copied it. Okay, so copy. And what I will do, now that I'm done with that and it's on in the clipboard, I'm going to go up and paste it. So I've got a couple of options. I could paste it into a subroutine, or I can paste it into the main program. As a matter of fact, I think I'll just do both. So I'm going to insert some space and Control-V, paste those rungs. Now notice that my rung numbers are not correct, right? I've got 9 here. I need 10, 11, 12, 13, and then my last rung, I don't want to redefine it. I want that to be rung 14. Now let's get rid of the extra space. There we go. And I'm going to do a, well, let me, before I get carried away here and overwrite my program, I'm going to save this as a separate program. So file save as, and we'll just say demo. Now notice it's a .txt file right now. I'm going to change to all files and leave this as .rsl on the end. So let's see, that's demo, that's a new file. I can save, it won't overwrite my old programs. And just to show you how this works in the subroutines, just for the fun of it, I am going to also put this code into subroutine 5. So another Control-V there. It's the exact same code. Obviously there's no real point in doing this. And then I have to change this rung number to 4 so that the end rung for that subroutine is present as well. Okay, so we should see the data in subroutine 5 as well as, or the new program in subroutine 5 and the addition to the ladder. So I've just saved it. Now let's open it and see if it worked. So let's see, drag this over just a bit. Yeah, there it is. Demo. Open up. You'll notice this looks exactly as it did before. And if it worked, we should see that code, there we are, right here. So we've got, let's see, this move was the last mapped move, so these 1, 2, 3, 4 rungs came from that other program. And notice I didn't have to enter every rung and every instruction and copy it laboriously. I just copied and pasted, changed some rung numbers, and I was done. Also in subroutine 5, there we are. I was able to paste the code there as well. So I hope this saves you some time in any project you might encounter where you need this technique.